So the first question says, a location in space that does not have a size or a shape. It's called a point. Because a point is just a thing that's sitting there. Now, when we put it on a coordinate plane, it's on a coordinate plane and we can give it coordinates, but it can just sit wherever it wants to sit. Okay? Number 2 says, a line that has one endpoint and continues indefinitely in one direction. That would be like a point and it continues. What would that be called? It's not a line because there's a point on one side of it. A line keeps going on both ends. But it's a ray. Okay, a set of connected points without endpoints. So that means it goes this way and it goes this way and it never ends. That's a line. Yes. Next, a set of connected points with two endpoints. So it almost looks like a line except it stops. That is a segment. The point where two intersecting lines meet. So there's two lines. They meet right there. And it's called intersection. Lines that cross or meet at some point. They could be perpendicular, but not all lines that cross are perpendicular. So it's another word. Intersecting lines. It kind of gave you the clue up there in the previous problem. Number 7. A geometric figure formed by two rays that connect at a single point or vertex. So a ray, you know how it stops and keeps going on one end. So you put two rays together. So here's a ray and here's a ray and you put them together and they intersect right there. So what does that thing right there make? It's not a triangle because it doesn't have a third side. It's just an angle. Okay, when you connect those two things together, we have an angle. Number 8 says the points on an angle, or like the point where that angle met. It's vertices or vertex. We're just going to call it the vertex right now because most of the time on an angle, especially like an angle that I just drew in number 7, it only has one vertex. Now, if you make a triangle and then look at all the angles in the triangle, there would be 3 points that you would be interested in. There's 3 vertices. We'll just call it a vertex for now. Okay, there's a word that means the same. And when you talk about that word, you're talking about how big it is and also the way that it looks. Okay? So it is congruent. When we say two things are congruent, they're the same size, they're the same distance, and so we're just leaving the words as the same for now. Okay, next, an angle that measures in 180 degrees. So we talked about, I heard some of you earlier tell me there's a right angle and there's obtuse and there's acute, but there's a different one that measures 180. That's exactly 180. Anybody know what it is? If it's 180 degrees, it's like this. So it almost doesn't even look like an angle. It looks like a line. It's called a straight angle. Okay, next. An angle that measures 90. That one's right. An angle whose measure is less than 90. Acute. In elementary school, you probably heard your teacher say, "It's so little, it's very cute." It's a cute. Angles who measure, an angle whose measure is greater than 90. Obtuse. It's very big. Okay. Number 14 says angles whose measure add up to 90. Okay. In 13, this is really just talking about one angle. That really S shouldn't be there. It's just talking about one angle. But in 14, it says angles who measure up to 90. So it's two angles that you put together that make 90. In a picture, it might look like this angle and this angle add to 90. You know what those two angles are called? Complementary. So complementary angles add to 90. Well, if complementary angles add to 90, what kind of angles add to 180? Anybody have an idea? Starts with the S. Supplementary. Either memorize it, or somebody showed me a trick one time to help you remember which was which. Let's see if I can do it. So if I make a C, I can make a 90 with the C. Okay, for complementary. If I have an S, I can make 180 with the S for supplementary. So 180 has an S in it. The 90 has a complementary. Parallel lines never cross, and they have the same slope. We won't be doing much with the fact that they have the same slope, although there's times that we might have to need that when we're trying to figure out if the lines are parallel. Lines that meet at a 90-degree angle, those are perpendicular. Angles that are across from each other and are congruent. Okay, I'll show you a picture. There's two angles that, or two lines that cross each other, and the angles that are across from each other are the angles it's asking about. So those two angles maybe, or the two angles above. So the two angles at the top or the two angles at the side. Anybody know what those kind of angles are called? Vertical angles. And if you look at those angles, they do look like they're the same size, don't they? If you look at the purples that I just drew or the yellows, they look like they're the same size. They are. Vertical angles are congruent. Okay, number 19 says angles that are beside each other. They don't have to be congruent. They can be different sizes or they can be the same sizes, but they're beside of each other. Adjacent. So vertical angles are across from each other. They're always congruent. Adjacent angles are just two angles that are beside each other. Okay? Any questions so far? I mean the symbols. Let's look at the symbols. So some of these, there's ways that you have to write it or things that you might see that will help you understand what it's asking you. So when you see a symbol that looks like this, it's talking about a segment BC. So it like puts a BC and then puts a little line over it without arrows. That means it's a segment. Okay, so if it has a line over it like that with no arrows, that means we're talking about a segment. Okay, a ray, it still has your BC, but your ray don't have that little segment thing. It just has like a little arrow on one side. A line has an arrow on both sides, because that's what a line is. All right, length of BC. If it asks you to find whatever, it's asking you to find the length. Okay? So if it looks like this, BC, without any kind of line over it, it means find out how big it is. Find out how long it is. Okay, angle ABC. you put a little angle in front of it, and then ABC. That means we're talking about an angle if it has that little angle symbol. Measure of angle ABC, that if they want to know, well, how big is that angle? Is it 50 degrees? Is it 90 degrees? Is it whatever? Then you put a little M in front of it. That means figure out how big it is. Right, if you see a symbol that has a triangle in front of it, that means you're talking about a triangle ABC. Okay, if you see something with two lines going up and down, that means they're parallel. If it tells you that L is parallel to M and they put those two little lines right there, the parallel is what they're talking about. Perpendicular is another symbol you're going to see, an upside down T, but that kind of looks like 90 degrees there, and so we call that perpendicular. Technically, what's going on there is there's a little box, and that little box represents 90 degrees whenever you have it like that. Congruent is two little equals with a little swirly thing above the equals. And the reason that you say it that way is because if you're talking about numbers, you can say that 5 equals 5 and you put an equals in between it. But if you're talking about like figures, we might say that that stop sign is congruent to that stop sign because they're the same size, they look exactly the same, they have the same letters, the angles are the same, all that kind of stuff. But are they really the same? They're not the same sign. If we're talking about the one over here on this road and the one on that road. So we say they're congruent because they look the same and because they're the same size and the same figure, but they're not really equal to each other because they're not the same. So that's why we write that little symbol there, okay? And it has that little curvy thing on top. Similar is one little thing that has that curvy thing. When we talk about people, when we say that people are similar, we might be talking about their personalities, or we might be talking about, I don't know, their height maybe, okay? But they're not exactly the same. Okay, when we talk about similar in geometry, we're talking about the fact that their proportion is the same. So maybe you have this little bitty triangle here, and you have this really big triangle here, and we can say those two things are similar as long as their proportion is the same. Okay, and so we'll get to that, but that's the symbol for it, is that little curly thing. All right, another thing we're going to look at. And this is all the vocabulary that you really have. There's a few more things, but mostly this is everything. So if we can just get it all in one day, we can get it out of the way. There's some other thing that we're going to do, and we're going to do it today with, it's called proofs. And you can do it with geometry, you can do it with algebra, you can do it with lots of things. Today we're just going to be looking at it with algebra. So we're going to have an equation, and we're going to solve an equation, which you guys can do because you've been doing it all semester long. But then what you're going to do, besides just solving it, is you're going to tell me a reason why you can do whatever it is that you do in the equation. Okay? And I'm going to give you an example real quick. So let's say that you have x minus 5, or 3x minus 5 equals 10. Okay? Well, I could say, I could add 5 on both sides, and I could get that 3x is 15. Do you agree? Okay, then I could divide both sides by 3, and I could get that x is 5. Do you agree? Okay, well, what you're going to do, instead of just solving it, is you're trying to figure out, well, why can I go from here to here? So if that first step, what is it that we did on both sides to get that 3x equals 15? You added 5. So the property would be called the addition property. And what you're going to be doing is you're just going to figure out what property it is that makes you say that that thing is true. And that's what that means up there, addition property of equality. Okay, if I go from 3x equals 15 to x equals 5, how do I know I can do that?
Division property.
It's the division property. Because you can divide both sides by 3. That's what that is right there. Okay? Now, I didn't tell you about this very first one called given. Usually the very first step in problems are given to you. I didn't say, okay, solve any equation to make it up on your own and let's hope that we all get the same answer. I didn't say that. Okay? I gave you the equation and said, okay, here's the equation, I want you to solve it. So the very first step is usually the given because it's what you start with. Okay? So given is what you start with. It might be a starting equation, or it might be a starting, it might tell you in the problem, we're starting with this amount, or whatever. Whatever they usually start with is the given. Okay, so I think you understand addition and division. Subtraction and multiplication are very similar. Subtraction just means you're going to subtract something on both sides. Multiplication means you're going to multiply something on both sides. Okay, just like I was solving down there. So I think we understand those right there. Okay, next is the distributive property. If you have 2 times x plus 5, and you say that 2x plus 10 is what that's equal to, that's the distributive property. If I give you an equation and I worked out that 2x plus 5 somehow and got 2x plus 10, then that's called the distributive property because I multiplied everything by 2. It's not the multiplication property because I didn't do it on both sides. Okay? Alright, substitution. If I tell you in a problem that a is 2, and then maybe a plus b equals 3 is given, and I decide to put the 2 right there, that's substitution. Because what I did is I put the 2 wherever a was. I substituted in what it told me. Okay? So if you see something where they substitute something like that in, that's substitution. Okay? Symmetric is kind of different. I'm going to erase this part about substitution so I can write it. But symmetric is not something you'll see very often. But you know how sometimes when you solve an equation, sometimes you guys move it to the right, sometimes I move it to the left. And you might get 4 equals x, but I might get x equals 4. Symmetric property says, well, you can switch it around. If 4 equals x, that means x equals 4. Does that make sense? Okay, transitive property. It's another one you will not use very often, but I just want to show it to you. If you have a equals b, and the problem also tells you b equals c, what does that mean about c? C equals a. That's what the transitive property says. Transitive property says if I know that a is something and that something is also c, then a and c got to be equal to each other. It's kind of obvious. Like I said, you won't really use it much, but it's just another property to know. Okay? And the last property. You won't use it very often either. But if I tell you that x is 5, well, x is still 5. That's the reflexive property. Reflexive property just means whatever you start with equals itself. And if you need to write it down, it's called the reflexive property. The ones that you're going to need, as far as what we're going to look at today, are mostly these here, given through substitution. That's most of the ones that you'll be looking at. Okay, these others are just some properties that we need to list, but you won't really be using them much. Okay. Okay, most of the time the statements will be given to you, and you might be able to look at the problem and it'll say, give and improve, and then it'll show you the statement side. Okay, but that very first one is usually given, so our reason on that one is given. Okay, so what did we do on the first step? We did multiply, but it's called the distributive property since we went from the parentheses to not the parentheses. You can say distribute or distributive property, however you want to do that. Okay, what did we do next after we did the distributive property? We subtracted 6. And you see how, like, our reason matches what happened to get to that point? It's not really like this is going to be subtraction. And that doesn't look like we subtracted, but it's what you did to get there. So it's like you have to look in between even though those steps aren't there. So this one's subtraction. And then what did we do last? Division. Okay. Let's talk about the reasons here. So the first one, like I told you, the first one's always given. Okay, what did I do after the given step?
Subtract.
We subtracted x on both sides, so we're going to call that the subtraction property. Okay, what did we do next on both sides? Addition. And then lastly, we divided. Okay. One more property I hadn't really talked about, and I just want to show you real quick. If I were doing this one, and my next step said 5x plus 5 equals 10, and you add those two together, this is really called combine like terms. You are adding, and I probably wouldn't count it wrong if you put adding, but I'm not adding on both sides the way you are on the equation. You're just combining the 2x and the 3x together, and because they're on the same side, we really call that combining like terms. So I just wanted to make sure you saw that.